Let's see the properties of the dot product. Properties of the dot product. Under properties of the dot product, if we, for example, given A equals 2i plus 3j minus k, and vector B which is equal to I plus 2j plus 3k. Now let's find A dot B. From the definition, A dot B equals 2, 3, minus 1, the component of vector A, 2, 3, and minus 1, dot with the component of vector B, which is I, 1, J, which is 2, K, which is 3. Then A dot B, as we have seen before, A dot B equals AX BX plus AY BY plus AZ BZ, which is equal to 2 times 1 AX BX, 2, 3 times 2, which is 6, minus 1 times 3, minus 3, then add them, 2 plus 6, 8, minus 3, which is 5. If we take B dot A, B dot A means 1, 2, 3, 1, 2, 3, dot with 2, 3, and minus 1, 1 times 2, 2, 2 times 3, 6, 3 times minus 1, minus 3, this equals 5. From these two results, we observe that A dot B is equal to B dot A. This is what we call commutative property of the dot product. Commutative property of the dot product. Again, the first example. Second example, if we take A dot A, when a vector dot with itself, then what we have? A, 2, 3, and minus 1. Again, dot with itself, which is 2, 3, minus 1, 2 times 2, 4, 3 times 3, 9, minus 1 times minus 1, 1, their sum equals 2, 9 plus 1, 10, plus 4, which is 14. Now compare it with the magnitude of A. First, let's find magnitude of A. Magnitude of A, which is equal to AX squared plus AY squared plus AZ squared, which is equal to the square root of AX 2 square, which is equal to 4, plus 3 square, which is 9, minus 1 square, 1. This is equal to the square root of 9 plus 1, 10 plus 4, which is 14. When you compare the dot product of the vector with itself and the magnitude of a vector, then we have that A dot A is equal to simply the magnitude of A squared. This is the second property of the dot product. The third property, if the dot product of two vectors a dot b equals 0, then either of a or b, either a or b, a null vector, or a zero vector, or they are perpendicular with each other. Perpendicular with each other. This property is said to be orthogonality property. Orthogonality property. Example. Given a, which is equal to 3i plus aj plus 4k, and vector b, which is equal to I minus 2j plus 3k, for what value of a, vector a and vector b and b perpendicular. Now, if they are perpendicular with each other, solution: if a is perpendicular with b, then a dot b equals 0. From this, a, 3, a, and 4 dot with a vector b, the magnitude of I, which is 1, minus of 2, and here you have 3. Dot product ax bx, 3 times 1, 3, minus 2 times a, minus twice a, 4 times 3, which is 12. If they are perpendicular with each other, this sum, which is 3 minus 2a plus 12, this sum equals to 0. Then, for what value of a and b perpendicular, then 3 plus 12, which is 15. When we shift to the right, it becomes twice a equals minus of 15. Minus over 2 cancel, then a is equal to 15 over 2. If the magnitude or the value of a 15 over 2, then both vector a and b perpendicular with each other, or they are orthogonal vectors. This is all about the properties of the dot product. Now let's see the application of dot product. Application of dot product. Under application, we may see two applications of dot product. The first application of the dot product, to find angle between two vectors. For example, this vector A and here vector B, angle theta. Then angle theta, which means from the definition of the dot product, A dot B equals AX, or magnitude of A times magnitude of B times cos theta. Then angle theta, which is cos theta, equals A dot B over magnitude of A times magnitude of B, or this is equal to AX BX plus AY BY plus AZ BZ over magnitude of A times magnitude of B. This is the first application of the dot product. Now let's see the second application of the dot product, which is finding the projection of one vector over another. The second application of dot product to find the projection of one vector over another. Again, from this diagram, to find the projection of one vector over another, for example, if we take the projection of A on B, first we draw a perpendicular line from A to B, then the adjacent side of the right angle triangle, the adjacent side, which is this one, is given by from trig identity becomes the adjacent side, and the adjacent side ማለት adjacent equals hypotenuse times cos theta. But the adjacent side, which means hypotenuse magnitude of A times cos theta. Therefore, magnitude of A cos theta, which is the adjacent side, is the projection of vector A on vector B. Then the projection of vector A on vector B, which is equal to magnitude of A times cos theta. Similarly, the projection of vector B on vector A is given by magnitude of B times cos theta, which is equal to, since it is one application of the dot product, from the definition A dot B equals magnitude of A times magnitude of B times cos theta, but projection of A on B, which is equal to magnitude of A times cos theta, magnitude of A times cos theta, divide both sides by B, then this is equal to A dot B over magnitude of what? B. Similarly, projection of B on A equals A dot B over magnitude of A. This is all about the dot product. Next time we'll see the cross product. ቻናላችን ላይክ፣ ሼር፣ ሰብስክራይብ በማድረግ እንድታውቁ እንጠይቃለን። አመሰግናለሁ።